This is the second video in our series where we're discussing the board paper 030/2/4. In the first video, we discussed the first 10 questions of section A, and this video is going to have the remaining 10 questions, questions 11 through 20, and that will complete section A for us. Let's read this first question here, number 11. Two lines are given to be parallel. The equation of one of the lines is this, 3x minus 2y equal to 5. The second line, we want to see which of these can be the equation for that. Now, this is a page from your book. It says that if you have two lines, two equations like this, two linear equations, you see both of them in two variables, and if they're parallel, then this is what they will satisfy. This is the ratio of the coefficients of the x's, this is the coefficients of the y's, and these are the constants. So this is the condition that they have to meet. Now in my case also, if it is parallel, I know one line here already. So 3x minus 2y minus 5 equal to 0, just to put it in exactly this form. The other line is, suppose, ax plus by plus c equal to 0. Then according to this condition, I should have 3 upon a equal to minus 2 upon b different from minus 5 upon c. This is what I want. Now if I work on these two pieces first, what will I see? Let's look at the choices. So if I have choice A, then my A is 9 and my B is 8. So 3 by A is 3 by 9 and 8 as B will make it as minus 2 by 8. Are they equal? No, they're not. This is 1 by 3, this is minus 1 by 4. So the first choice is out already. It did not satisfy the first piece. Remember, I'm not even going to C because this already failed at the first step only. So this was about choice A. If I tried the same with choice B, then A is minus 12, B is minus 8. So this is going to be 3 upon minus 12 and minus 2 upon minus 8. Now if I check this is minus 1 by 4, but this is plus 1 by 4. Be very careful of your signs. So this is also not equal, because of which I can reject choice B as well. Now moving on, choice C, my A is minus 12, B is plus 8. So same thing again, you are just going to put in the values of A and B. This is going to be minus 1 by 4 at both places. So the first part is clear here. So I will check the second part here as well, because if that also works, then this will be my answer. So what is minus 5 upon C for me then? Well, if I get it here, it'll be minus 7 equal to 0. Same thing if I do it here. We are working with choice C. So in that case, 5 upon C will be minus 5 upon minus 7. And this is definitely not equal, because that's just 5 by 7. So the condition that we have here is satisfied when you come to choice C. So the correct answer is C. Okay, question 12 now. Three vertices of a parallelogram ABCD are given here. So here's just a rough sketch of how that parallelogram can look. This is not according to how the coordinates actually are. The ordinate of the fourth vertex D is, so what is ordinate? When I have any point as x comma y, then the y is what you call the ordinate. X is known as the abscissa, but that's not what we need here. Okay, so if this is my point D, x comma y, then what I want is y. Let's highlight this. Okay, now how do I get this? What are the properties of a parallelogram? I'll have to rely on them. One property from the book that we have is diagonals of a parallelogram bisect each other. That is, if I join AC and BD, then they will meet at a point here in the center, and that point will cut each diagonal into two equal parts. So that means the midpoint of one diagonal, wherever that is in the middle, is equal to the midpoint of the other diagonal. This is what we're going to use here. Now, how do I get the midpoint is another thing you have to know. So if I have 2 points A and B, then the midpoint is given by this. You take the average of the x coordinates, that gives you the x of the midpoint, and average of the y coordinates, which will give you the y coordinate of the midpoint. So with all of this now, let's try to do this. Here I've drawn the diagonals also. Now if I focus on AC, then this midpoint O of AC will be what? So let's look at what A and C are. This is 1, 4 and 5, 8. And I know how we get the midpoint. It is the average of the x's, so 1 plus 5 by 2, and the average of the y's, 4 plus 8 by 2. So this is going to give me that the coordinates of this midpoint are 3, 6. Now this precisely is also the midpoint of BD, because the diagonals bisect each other where they meet, right? So if I pick up B and D now, B is minus 2, 3, D is x, y, even then the midpoint is the same. But had I tried to find the midpoint using my method, it would be average of the x's, average of the y's. Like this, I would have had to calculate it. But now I know that this is equal to 3, 6, because that is what we already found here in the first step. Now all I can do is just equate my x's, equate my y's, but since I'm only interested in the y part, I will only work on this much. So what I have is that 3 plus y by 2 is equal to 6. When you solve this, you get the value of y as 9. So y equal to 9 is the correct answer, choice B. Time for question 13. Okay, so triangles ABC, DEF, we're given that F is equal to C. So if we mark that here, this angle is equal to this angle. Angle B is equal to E. We mark that. This is B and E. And we're also given that AB is half of DE. So AB upon DE, the ratio is 1 by 2. Then the two triangles are what? Now you need to understand the difference between congruence, similarity, because that is what all of the choices are talking about. So here it explains that two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio, or that they are proportional. That is what it means to be similar. Congruent is something which has the same shape, like it is similar, but it also has the same size. So the two triangles in that case would just be overlapping triangles. For me here, because the ratio is 1 by 2, they do not have the same size, so they cannot be congruent. Are they similar? Well, yes, they are similar, because two angles here are equal to two angles here, and we have the AA similarity criterion. Two angles equal here with two angles on the other side, the two triangles have to be similar. And then this little ratio thing here just confirms that they're definitely not congruent. So they are similar but not congruent, making the answer B. Question number 14. In triangle ABC, right angled at B, so this 90-degree angle that you see here in the picture, this is where B is, and the others are A and C. That's how you get ABC. We are also given that sine A is 7 upon 25. Now this is angle A. Sine means what? Sine is opposite upon hypotenuse. The question is, what is cos C? Okay, now C is here. Before I get into all of that work using 7 by 25, finding the other side, the one missing side, the adjacent side to A, then using that to find cos C, it is much better that I use this property. I will still put both methods out here. So for sine A, opposite upon hypotenuse is 7 upon 25, while cos C is nothing but adjacent side upon the hypotenuse side. So what is the adjacent side to C? That's again 7, and hypotenuse is still 25. So this is one way of seeing that the answer is still 7 by 25. Another way is to see that sine of 90 minus A is equal to cos A whenever your angle is between 0 and 90. In this case, you see that if A is here, C is here, you already have that A plus C is 90 degrees. That means sine of one angle has to be equal to cos of the other angle. Just observe this property carefully. What is it that you're seeing? 90 minus A and A, it's just two angles whose sum is 90 degrees. Whenever that happens, the sine of one angle is equal to the cos of the other one. And here also, because the sum is 90 degrees, sine of one angle is equal to cos of the other. That way also you could have thought that it's equal, but it's easy to see it on the triangle as well. Question number 15. The minute hand of a clock is 84 centimeter long. So this is a clock that I've drawn, and this here is the minute hand. I've also written the length. The distance covered by the tip of the minute hand, which is here, the distance covered by this tip from 10:10 to 10:25 a.m. is how much? So really, obviously, as time goes by, the minute hand is going to move forward. So after a while, after these 15 minutes to be precise, it will reach somewhere else. So suppose it reaches here, then we can see that the tip has made a movement. It has come from this first starting point to this final point, and this is precisely the distance that we want. Now this is an arc on the circle, so we need to understand how to get the length of an arc when the angle here at the center is theta. That's the formula that we have from the book. But do we need to get into that, or can we just directly use the time that we have? Well, we can if we just understand how a clock works. When it's a minute hand, then in 60 minutes it goes from the 12 point and comes back to the 12 point, right? So in 60 minutes, a minute hand makes a complete 360-degree rotation. So here it is just 15 minutes. How much is going to happen in that? Well, this is 360 upon 60 times 15. You calculate what this comes out to be. This is going to be 90 degrees. What that means is I really just have a quarter of the clock covered in the time that I talked about. It will not look like this, it will instead look like this. But that doesn't matter, you can still calculate the same way. Well, now you have the theta that you were looking for, the angle at the center. So length of the arc is now straightforward. It's 90 by 360 times 2 pi r, where your r is 84. Just make the calculations and you're going to get 132 centimeters. Question 16. The probability that a drawn card from a pack of 52 cards is neither an ace nor a spade is what? So we need to understand what the different kinds of cards there are. So this page, you can pause the video and read everything from the book, which is about all of the cards in a deck of 52. We are interested in ace and spade, so we really need to understand how many of each do we have. So we have 4 aces in the entire pack, and we have 13 spades in the pack of 52. Now you want a card that is neither an ace nor a spade. Well, first of all, understand if I want neither of them, then I'm actually going to calculate this by 1 minus probability that it is an ace or a spade. I want the reverse of that, right? So first I'll see what is the probability that the card I get is one of these, and then I'll just subtract that from 1. So probability that it is an ace or a spade. So when you do or, you need to add, right? But you also need to take care that there is no extra counting. There is nothing common. So how many aces there are again? There are 4. So I'm trying to calculate the favorable outcomes. Plus for or, how many spades are there? 13. But there is one ace of spades. There's one ace that has spades on it. So that one is counted both times, in aces also, spades also. So we subtract it once. This is favorable, and my total is 52. Now when you simplify this, it is 1 minus 16 upon 52. Now cancel that, you're going to get 8/26 first, then it's going to become 4 and 13. Overall it's 1 minus 4 by 13, which is nothing but 9 by 13. So the correct answer here is choice A. Question 17. 3 alarm clocks ring their alarms at regular intervals, 20 minutes, 25 minutes and 30 minutes respectively. The first alarm, that means, will go off after every 20 minutes. The second alarm will go off after every 25, and the third after every 30 minutes. They first beep together at 12 noon. At what time will they beep again together for the first time? So they're not going to be together throughout, right? Because if you start at 12, then the first alarm will be 12:20, 12:40, then 1. But the second alarm is 12:25, 12:50. So it's not the same every time. We have to see when will they be the same really. So we are looking for that one multiple which is common to all three of these. That's when all of the alarms will reach at the same point. Now, actually the number of common multiples is infinite, but I am interested in the first one that comes. That means I am interested in the least common multiple. Now, how I calculate that? It's the product of the greatest power of each prime factor. Well, prime factor first of all tells me I have to do some factorization. So 20 is 2 squared times 5. 25 is 5 squared, and 30 is 2 times 3 times 5. What is the LCM then? As we said here, it's all prime factors that you see with their greatest powers. So we see 2, 3 and 5. What are the greatest powers? For 2, the greatest power visible is 2. For 3, it is 1. And for 5 also, it is 2. So this is going to be 2, 1, 2. You see what this comes out to be? This is 300, and since we were in minutes, this is 300 minutes. When you do that in hours, it is 5 hours. So starting at 12 noon, what is the time after 5 hours? It's 5 p.m. Correct answer, choice C. Question 18. A quadratic polynomial, the product and sum of whose zeros are 5 and 8 respectively. So the product is 5 and the sum is 8. Then what is that quadratic polynomial? Well, this is relatively straightforward. This is a page from your book. If alpha and beta are the zeros, then this is what your polynomial is. Now here, just observe that I don't have the zeros given. I have the product and the sum given, which is precisely what you see anyway in the final quadratic. This is the sum, this is the product. So we will directly use this final thing here. So our polynomial is k times x squared minus alpha plus beta, which is the sum, and you know the sum is 8, so 8x, plus alpha beta, which is the product, and you know that is 5, so that comes here. Now this, when you see, matches with choice A. That's the correct answer. Question number 19. Points A and B, you have the coordinates here, they lie on a circle with center O. So this is the circle, this is the center O. The values of y are what? Well, simple question here. When you have any point on the boundary of a circle, all of these are equidistant from the center, wherever that point may be. So if I randomly draw this to be A and this one here to be B, then the distance between A and O will be equal to the distance between B and O. Now, how do I calculate the distance between any two points? Where you need the distance formula. So it's stated here. So if I work with AO first, then this distance is going to be 2 minus of minus 1 whole squared plus minus 3y minus y whole squared. When you do the simplification, it's 9 plus 16y squared. So this is what AO is. Similarly, let me write down BO. There you go. So here first part becomes 9, and this I just remove the minus because the squares are anyway going to take care of them. Now AO is equal to BO, so we are going to put 1 and 2 equal and then see what we get. Alright, so this is what it will first look like when you put AO equal to BO. Then you will just square both sides, so both of the square roots will vanish and you will be left with this expression in terms of y on both sides. Now the 9's get cancelled on both sides, so now all you have is this. Open the identity on the right hand side. You're going to get 9y squared plus 49 plus 42y. Further simplification opens this up like this, and then you take all of it on the same side, on the left hand side, and then you see that 7 comes out common, which gives you the simplest quadratic equation here, which when you solve, you're going to factor this. This is going to give you y as minus 1 and 7, and you see that on your choices here, minus 1 and 7 is right here, choice B. Question 20. Given that sec theta is square root of 2, we want to find the value of 1 plus tan theta over sine theta. Now what is sec? It is hypotenuse upon adjacent. So for us here, if this is theta, then hypotenuse is here, root 2, and adjacent is here, which is 1. Now you can use Pythagoras theorem to get AB. That is going to be 1. Now finally, what is tan theta? Tan theta is equal to, if you see here, opposite upon adjacent. So for this, theta, opposite and adjacent are both 1. So the value of tan theta is 1. For sine theta, it's opposite upon hypotenuse. So it's 1 upon root 2. So with these values, I just have to do the calculation. So this is going to be 1 plus 1 in the numerator, and my denominator has 1 upon root 2. So this is 2 divided by 1 upon root 2. The root 2 comes here on top, and the answer becomes A. Stay tuned for the next set of questions. This completes section A. Next video, we'll do section B.